All right, guys, we are working on some more of what we did yesterday, but with different place on the pink sheet, okay? Towards the bottom, it says double angle relations and half angle relations, okay? We're going to talk a little bit about half angle ones. They're good to know about, but I'll be brutally honest and tell you I don't think I put any on this quiz. I should, but I didn't. So if it shows up again, you might get half angle, but I focused on the double angle this time. All right, everybody see where that is on their sheet? Okay, before we get started, I'm going to do a super fast review of completing the square, just as a warm-up, because next week this is going to hit hard. When you do completing the square with two variables, you want to separate the variables. Okay, does everybody see what I did? I put the x squared and the 2x together and the y squared and the 6y together, and I'm going to move this 5 over to the other side. So I'm going to add it over to the other side, and I'm going to put 2 blanks. Anybody remember how to complete the square for that? Yes, you divide that guy by 2, so we get 1, and then we square it, and that goes here. Now, do you understand that the underlined red and the parenthesis red are equivalent? Okay, but we did add 1 to this side, so we have to add a 1 to the other side. And if we do the y's in green, we take half of this guy right here, so we get -3. When we square it, we get 9. So now this whole thing is equal to this. We ended up adding a 9 to that side. Notice there was no coefficients, okay? We'll deal with coefficients in a minute. In other words, like there was nothing in front of this x squared or y squared, okay? So when we get done over here, we end up with what, 15? Okay, this would graph as a circle whose center is at -1, 3 with a radius square root of 15. More on that next week. All right, I'm just going to do one more down here. To complete the square for a parabola, okay, you are going to have coefficient. I'm going to do one with a coefficient here, okay? The way I like to do these is I'm going to move the 76 over to the other side with the y, and then I'm going to leave on this side here, and I'm going to factor out a 2. What's left then? -12x, and I'm going to put a blank in there. Okay, really important. What is going to happen to this blank? It's going to get multiplied by 2, right? All right, so if I complete the square here, I get x minus 6. Everybody good? Half of that. Squared is 36. Now this underlined is equivalent to this. All right, I'm going to bring down the 2. But what I really added here was a 2 times 36, or 72. So I get a y minus 4 over here when I combine those. And then eventually I'll add the 4 over here. This is vertex form. Remember that? Okay, so the vertex of this parabola is at 6, 4. We're going to use a little different form next week. We're going to leave the 4 over here and do some crazy business, and we're going to find focus and directrix. You may have had that before. All right. Today's learning targets, guys, we're still doing some of this, okay, just doing the trades with half and double formulas, but then we're going to do a bunch of equation solving using those half and doubles. All right. So there on the back of your yellow sheet, and maybe on your notes, I don't know where it is on your notes, this is the important one that Gupta says you need to know for calculus, okay? Sine 2 theta is 2 sine theta cosine theta. All right, notice that for cosine of 2 theta, there's 3 choices. Those are all equivalent to cosine. Does everybody see that on your sheet? I like how it is on here. It shows clearly that they're all 3 under cosine, right? And then tangent of 2 theta has one on your sheets, but this is also possible. We talked about this yesterday, right? Tangent 2 theta could also be just sine 2 theta over cosine 2 theta. All right? Here's an example. They said, here's the sine. I think that says negative 7/25, and it gives you an interval between pi and 3 pi over 2, means they had to draw it in this quadrant. Sine is opposite over hypotenuse. In this quadrant, it would be negative, and so would the x, right, guys? They did Pythagorean theorem to find the x. All right. Then they wanted to find sine of 2 theta, so they plugged in values 2 times sine times cosine and got this. To find the cosine of 2 theta, they picked one of the three. You can use any one. They all will give you the same answer. They did 2 cosine squared minus 1 and came up with this lovely exact answers. Then for tangent, first time they put it in the lovely tangent formula. Does that look lovely? The second time they said, well, wait a minute. If we already have sine and cosine, can't we just do this divided by this? And remember, it will flip over and the bottom will go away. So they got, to see where they got the 336 over 527? Okay, we're going to do these. All right, let's start with this example. It says if the sine is 1/4 between 0 and 90. So we're in quadrant 1. Where am I going to put the 1 and the 4? Opposite over hypotenuse. We good? What do I get for the missing side here? This is the hypotenuse, so we are adding or subtracting? Subtracting. 4 squared minus 1 squared is, okay. Now it says we're going to need to use, we're trying to find, sine of 2 theta. So the formula is 2 times the sine times the cosine. Well, they gave us the sine was 1/4. What's the cosine? Square root of 15 over 4. Okay. So then it's 2 times the sine value, which was 1/4, times the cosine, which was square root of 15 over 4. Okay, this 2 is over 1, so it's multiplying to the top. Everybody's good with that? Not going to lose this because of fractions, right? 2 times 1 times square root of 15 is 2 square root of 15. And the denominator, 4 times 4 is 16, right? And then what happens? I'm like, they did it wrong. But no, they just reduced, right? It reduced to square root of 15 over 8. For a minute, I thought I had something wrong. Like, that wouldn't be the first time. All right. Do you have this one done? New paper for you? No? Okay. Here we go. Why did I draw it there? Because it says pi and 3 pi over 2, right? So I drew a bow tie triangle here. The tangent is 4/3. Opposite over adjacent. Everybody got those in the right spots? Or y over x? What else? Something else I need to know. This is going to be a 5. But these both need to be negative. That was tricky, right? Because the tangent was positive. We had to remember that it's because those are both negative. All right. Now we're supposed to find, oh, lovely. Okay, all three of these. Sine of 2 theta is equal to 2 times the sine times the cosine. So can you give me some values? 2 times, what is the sine over here? And what is the cosine over here? Negative 3/5. We good? Multiply the top. 2 times 4 times 3 is 24, yes. Multiply the bottom. 5 times 5 is 25. There will eventually be some of these that you may have trouble doing a math enter because the numbers get really big, okay? So it may be good to make sure you know how to multiply across the top and the bottom. Because if you multiplied it all in your calculator eventually, and the fraction is like, well, even like this last one that was 3 digits, sometimes the calculator freaks out. All right, so we found one answer. The second one we're supposed to do is the cosine of 2 theta. 3 choices. Somebody pick one. The first one, cosine squared minus sine squared. Is that okay with everybody? It's nice we don't need a common denominator for that one. It'll get its own common denominator, okay? What's the cosine from our triangle over here? Negative 3/5 squared minus the sine squared. Negative 4/5. Okay, we square them first, so we get 9/25 minus 16/25. Everybody good that that became positive when we squared it? So when we subtract, we get a negative. Are we good? I'm going to talk about why that is in a second. But let's not lose our momentum here. Let's do tangent. Now, what's the easiest way to do tangent? Because we have already calculated sine and cosine, yes, this one, the sine divided by the cosine, which was this one. Okay? We can use the formula that's on here and it'll work, I promise. It's just a little more miserable. What do we get for an answer here? 24 over negative 7, right? Because these divide out. Okay, we just found the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. This would be a great quiz question that I didn't put on this next quiz. What quadrant is 2 theta in? Okay, what this means is there was an angle that took us all the way around to here. That's actually theta, okay? If we doubled that angle, where would we end up? Can you tell? How can you tell? The sine was positive, right? The cosine was negative, and the tangent was negative. What quadrant is that? 2. Sine is y is positive, so it's going up. X is negative, it's going left. Quadrant 2. Okay? If I were to talk about this as 180 to 270, guys, right? 180 between 180 and 270. If I doubled those, because it's 2 theta, I'd have somewhere between 360 and 540. But does that really help? Between the 360 and 540 could be in quadrant 1 or 2, right? So we had to know the signs to determine where it was. All right. But that's what we're talking about. If we were to go around twice that far, where would we wind up and what would be the exact values? All right, this says solve an equation using an identity. So the question is, this is a great quiz question, sine 2 theta minus sine theta equals 0. Now, somebody's going to try to pull out a sine already. Can you factor out a sine? No, but if I replace this with what? What's the trade for 2 theta? 2 times sine times cosine or cosine sine. I don't know what order it's listed on your sheet. Sorry. We good? Then what could I do? Now I can take out a sine and it will be left with what? 2 cosine minus 1. So I need where the sine is 0 or the cosine is what? 1/2. Everybody good? I rearranged that. Okay. And we're trying to find only between 0 and 2 pi. So looking at your pink sheet, where's the sine 0? 0 and pi, yes. And where's the sine positive, or cosine, sorry, positive 1/2? Pi over 3 and 5 pi over 3, is that right? Quadrant 1 and 4. Okay. That'd be a great quiz question right there. All right. So let's try this one. I don't know what to do with this. Do you have this question? No? Okay. Good. Just watch. I don't know what to do with that. I have to do a trade. Okay. Plan ahead. Out of my 3 choices, which one might be good if I know there's already a cosine squared in this question? Maybe 2 cosine squared minus 1? Okay. Okay, so next what? Can I distribute this negative? I'll have cosine squared minus 2 cosine squared plus 1 equals 1/2. Now what? Yeah, I can't factor till it equals 0, right? I could. It says negative 2. Oh, wait. Those are like terms. Whoa, stop, off power. Okay, those are like terms. I get negative 1 cosine squared. If I subtract this 1/2, I have plus 1/2, right? What do you want to do now? Cosine squared. How about I just subtract the 1/2 back over there and then divide it by negative 1? Is that right? Everybody okay what I did? Or just added the cosine squared to the other side, right? All right, now what? I got a square root, but I got to remember what when I do that? Plus or minus, okay? This is 1 over square root of 2, which becomes what? Square root of 2 over 2. Okay, where does that happen? 4 places, yes? Between 0 and 2 pi, I'd have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Good job. All right. I did not put these anywhere in your notes. They're all over the pink sheet, but I forgot to put them on your notes, okay? These are the half angle identities. And as far as, do you see how they all have plus or minus here? Okay. The plus or minus business, you have to determine, is it plus or is it minus? And we're going to talk about that a little bit later. Okay. It says here, when evaluating the tangent function for half angles, it's usually easiest to use the form tangent half angle identity. This one, it says, is easier to use since it has only one denominator. Okay. All right. Again, to determine which sign is appropriate using half angle, you're going to have to figure out which quadrant it lies in. Let me just give you a real quick example. The one we just did that was a quadrant 3 angle, remember we did that a second ago? We said it was somewhere between 180 and 270, yes? Because we think in degrees. Okay, if I was looking for theta over 2, what would happen? It would have to be somewhere between, what's half of both of those? Half of 180 would be 90. Half of 270 would be 135. So if I were to, theta landed me somewhere between 180 and 270. So half of theta would land me somewhere between here and here, which is which quadrant? Quadrant 2. If I'm in quadrant 2, do you know what the signs need to be for cosine, sine, and tangent? Okay, that's how you're going to determine that. We'll practice. Hate these with a passion. Okay, sine of 22.5. They want us to practice using one of these formulas. What is this half of? 45, right? So we're going to do the sine of 45 over 2. So what's the formula for a half angle 45 over 2? Look on your sheet. What do you get? It says sine theta over 2 equals plus or minus square root of 1 minus cosine over 2. Is that what it says, guys? Everybody find it? Okay. Is it me plus or minus 22.5? This is quadrant 1. It's going to be plus. Okay. Square root of 1 minus. What is the cosine of 45? Let me write it out here so that you know where I got that. Okay, the plus is because it's quadrant 1. Okay, now let's put values in. So it's going to be square root of 1 minus, you just told me root 2 over 2, right? Because that's the cosine, all over 2. Anybody want to cry yet? I do too. Do you remember my whole let's get rid of the fraction within a fraction by multiplying top and bottom by the common denominator? What's the denominator? So if I multiply through the top and the bottom by a 2, it's going to be weird, but it'll get better, I promise. 2 times 1 is 2, minus square root of 2 divided by 2 times 2 is just square root of 2. And the bottom is a 4, and it's all under a radical. Well, what happens is, what's the square root of 4 in the denominator? So the bottom gets out of the radical and looks like that. And then it's legal, right? Because we don't have a denominator square rooted anymore. I do hereby solemnly swear I'm never going to ask that question. That's just disgusting. But it is practice to manipulate these formulas. Okay. Yes, it is. It is gross. My door likes to open by itself randomly. Okay. We're going to do one in radians. Okay, I looked at this question a few minutes ago, getting ready to teach the lesson today, and I went, I have no idea what 11 pi over 12 is half or twice or whatever. So I changed it to degrees. It's 165, which is half of 330. Can we use that? Okay, which is half of 11 pi over 6 is 330. You with me? Does it matter if we do it in degrees? Is it going to have a different cosine value? No, we can do it in degrees. It doesn't matter. So if we want to just think of this as 330 over 2, what's the formula look like for a cosine over 2? Plus or minus 1 plus cosine of 330 over 2. Okay, is it going to be plus or minus? Well, half of 330 is 165. 165 is in quadrant 2, and quadrant 2 has what kind of cosine values? Negative. So it's going to be negative square root of 1 plus, what's the cosine at 330? Square root of 3 over 2? Okay. One more time for fun. We're going to multiply top and bottom by what? 2 over 2. So we get negative square root of 2 times 1 is 2. Square root of 3 divided by 2 times 2 is square root of 3. On the bottom, we get 2 times 2 is 4, in which the square root just makes it 2. Do you feel smart, at least, when you see that double radical? I kind of feel smart, like, yeah, I got that answer. All right. These are more examples of solving equations. I did not give you one like this. It says, what if you had a cosine squared x over 2? Just know, guys, for example, if it said sine squared x over 2, you would go to the sine x over 2 and square the formula. So what would it turn into after you squared that formula that's on your paper? Just 1 minus cosine over 2, right? It would get rid of the radical. Do you see what I'm talking about? The sine theta over 2 had a radical, but if you asked for me to square it, you would just get rid of the radical. All right. Let's try this. What is our trade here? I think you have this one, guys. We have cosine theta times, what is this trade for? 2 times the sine of theta times the cosine of theta. And it's supposed to all equal 0 on the interval 0 to 2 pi. Okay. Now what? Well, I could divide by 2. That would go away, right? So what else do I have? Cosine equals 0, or cosine equals 0, or sine equals 0, right? Or cosine squared equals 0. Does it matter? No. if you have x squared equals 0 or x equals 0, that just means x has to be 0, right? Either one of those? Okay. So I have either the cosine is 0 or the sine is 0, because they all multiply to make 0. My good old take your turn being equal to 0 game. Okay. Where is that true? The cosine is 0 at pi over 2 and 3 pi over 2. The sine is 0 at 0 pi. Do I include 2 pi? Nope, because of the parenthesis. We good? Okay, what if it said all solutions? Plus or minus 2 pi n on the back of everything, right? And yes, there's shorter ways to write that, but let's just go with it. All right, we're on 7b. Your homework tonight is to finish this worksheet. Okay. Let me see what else I got going. Oh, I'm almost done with notes already. Maybe we'll go back and let's just do this worksheet. What do you say? All right. What does this garbage at the top mean? This told me to draw it in quadrant 3, and this tells me the sign, okay? So alpha is really all the way around to here, but I'm going to put it in here. And the sign is negative 3/5. Did I label that right? So what do I get for my missing value? Negative 4. Okay, I'm going to list them over here just because it's easier for me later. So we now know the sine is negative 3/5 because we're going to be plugging these in a minute. You know what I'm saying? The cosine is what? Negative 4/5. And if we need tangent, it will be positive 3/4, right? Okay. So what's the formula for sine 2 theta? Two times the sine times the cosine. I'm just going to write it like that. And then on this blank, I'm going to plug in the values. What are the values we're plugging in? There's a 2. And then negative 3/5. And then negative 4/5. If I multiply all that, anybody? 24/25. This may be the question we just did. I don't know, but we're just going to keep going. All right. Cosine. 3 possible formulas. Pick one. The first one, cosine squared minus sine squared. Did I get it right? Okay. So what's the cosine value? Negative 4/5, and we're going to square it minus the sine squared, which is negative 3/5 squared. Uh-oh. A little bit different than the one we did, I think, earlier, because this one's going to come out positive, isn't it? We get 16/25 minus 9/25 equals 7/25. Did you get a positive? All right. Tangent 2 theta. Want to try the formula on the sheet once? Now. All right. Then just put sine over cosine. What will happen? Yep, 25s will cancel out, and you'll end up with 24/7. Can I take a commercial break and show you the formula? You don't have to. No. It would be 2 times the tangent, all divided by 1 minus the tangent squared. Okay? Look, this would be up top, 6/4, and it's being divided by, this would be 1 minus 9/16, which is 16/16 minus 9/16 is 7/16. When I flipped that one over, this would go in here 4 times, and I'd get 24/7. Is that what I got? Okay. Commercial break is over. All right. Now we're on to what? By the way, what quadrant did this wind up in this time? All of these 2 thetas this time wound up Positive, so what does that mean? 2 theta must have landed us in quadrant 1 this time. Okay, down here, what's the formula we're going to use for this bad boy? Okay, square root of 1 minus cosine all over 2. We got to determine plus or minus. Okay, for an angle that is somewhere between 180 and 270, half of that, okay, if I divide those by 2, I get between 90 and 135, yes, which would put it in quadrant 2. In quadrant 2, the sign is positive. I'm just doing these ahead of time. The cosine will be negative, and the tangent will be negative. Okay, so at the end, we got to make sure we got those signs right. But back to the question. 1 minus, okay, giant square root, 1 minus, what's the cosine value we're using? Negative 4/5, so that's going to turn into a plus. Okay. What does the top become? Use your calculator if you need to. 9/5 divided by 2. Do it on your calculator if you need to. What's 9/5 divided by 2? Which is 9/10, right? Square root of 9/10. Okay, you have to have exact answers. What happens? 3 over square root of 10, which is 3 square roots of 10 over 10. Whew. Did your head explode? Okay. You can do this on your calculator. Just let me show you before you freak out, okay? If I did 1 minus, parenthesis, negative 4 divided by 5, close parenthesis, and I hit enter. That's the top. Then it said divided by 2, and I hit enter. Then I change it back to a fraction and get 9/10, and then I have to deal with the radical, okay? But you can do it on the calculator. Don't let the fractions freak you out. Okay. What about cosine? The formula is the same, except it's 1 plus cosine over 2. So it's going to be 1 plus negative 4/5 over 2. Was negative still, right? So 5/5 plus negative 4/5 is 1/5 divided by 2 will be, did anybody do it? 1/10, yes? Did you type it in? Do you need me to do it on my calculator to show you? What happened to my calculator? Just kidding. Hit that stupid button again. Here we go. It's 1 minus 4/5. I don't even need parentheses. And then I have to divide that by 2. I'm at 1/10. Okay, what's the radical going to do? Square root of 1 is just 1, which rationalizes to square root of 10 over 10. And my answer is wrong. It needs to be negative. We already discussed this, right? The cosine had to be negative. Yes, it had a plus or minus out here. We had to choose which one to use, and for this one, we used negative. We probably should have used it from the beginning. Okay, good question. All right, and the tangent, what do you want to do? You want to use the formula? You use what? For oh yeah, there is, guys, on the sheets, remember there's 3 formulas for tangent. The first one is 1 minus cosine over sine. So it's 1 minus, this one doesn't have a plus or minus, so let's make sure it turns out the way it should. 1 minus cosine is negative 4/5. over the sine, which is negative 3/5. Okay? Up on the top, what does that become? 9/5 is divided by negative 3/5. 9/5 is being multiplied by the reciprocal, which is negative 3. Did anybody get negative 3? Is that what would have happened here? Look,
Yes.
3 of these garbages divided by 1 of these garbages with a negative sign will come out a negative 3 garbage, right? Okay, did it take care of the negative for us? Yes, it did. Because we had the signs right on these. What quadrant are we in for half of theta? We already discussed this early on, didn't we? We took it right there. Okay. This is just familiarity with trades. This is supposed to be an X, guys. There's a typo. That's supposed to be an X. Yeah, I've only used this worksheet like 1,000 times. I didn't fix it yet, did I? Or did I fix it? Okay. So it should say sine pi over 2 times cosine x plus cosine pi over 2 times sine x. It's not real clear what it wants here. You could, I suppose, use values, but I think what they wanted was just to trade it for something else on our sheet. What's sine cosine plus cosine sine? Sine cosine plus cosine sine is sine of a plus b, right, on the sheet? What are we going to put in? Pi over 2 plus x. I wouldn't put that question on the quiz. Simply, I would have put pi over 2 and pi over 7 or something weird. Because right now, I kind of feel like, well, how would I know if you wanted me to plug in a 1 and a 0 for those values, right? Okay. What about this guy? Cosine squared minus sine squared. We just learned today that this is double angle for what? Cosine. Now, you really should put the beta in. I know some of you are always like, I'm just going to use an X. But this one is about substitution. Okay, what's this? Tan minus tan over 1 plus, it's what? Tan A minus B. So I'm going to use alpha minus beta. Okay. What about this one? This is all over the quiz. 2 sine 3x cosine 3x. Ignore the 3 for a minute. It's this, right? Is equivalent to sine of 2 of those. So ours is equivalent to sine of 2 what? 3x's, which means you should write it as sine of 6x. Everybody okay with that? All right, couple more. Ugh, that's disgusting looking. But where's there a 1 plus cosine over 2 all under a radical? Cosine of something over 2, but what's our something? Or alpha over 2, which would reduce to cosine of 2 alpha. Okay? This would be a perfect quiz question. Sine cosine minus cosine sine. Sine A minus B, which in this case is sine of what? 30 minus 40. What is 30 minus 40? Oh. And I would be okay with that if it turned out that way on the quiz, but can you look up above? What is this equivalent to? Yeah, remember the even odd stuff? If there's a negative in here, it can come out front. So it's also equivalent to negative sine of 10. I would take either one of those if it were a quiz question. All right. Cosine, cosine plus sine, sine. Cosine, cosine plus sine, sine. Sine of, no, it's cosine, right? A minus B, which is pi over 3 minus pi over 4. Meeny, meeny, bobini, Hofbauer says you have to simplify that. Type 1/3 minus 1/4 on your calculator, and what do you get? 1/12. So this simplifies to the cosine of pi over 12. How we doing? Is that the whole side?
No.
Oh, we did these yesterday, though. We did one of them yesterday? No? They're just expanding and plugging in values. Does somebody want to pick one? B? I don't know which one we did yesterday. So if you expand this, you will have sine 60 cosine theta plus, am I doing this right? Somebody check me. 60 sine of theta, okay? Equals, now plug in the values for me. What's the sine at 60? And that's multiplied by some cosine. Plus the cosine at 60 is 1/2, and that's multiplied by sine. That's all they wanted. The first one I think will simplify better because pi over 2 has zeros and ones, right? But all right, so guess what? We did this. You have left these 5 questions, okay? It would be a really good idea if you also looked at, because we're going to do quiz review tomorrow. Did everybody pick? Oh, I should tell you about what you picked up at the door, right? The other thing that would be good for you to look at ahead of time that deal with these half and double, 9A, 1 through 6, okay? Look at 9A, 1 through 6, because I will go over those tomorrow, but, you know, it's review for quiz day, so you know how fast we're going to be moving, okay?